So we're going to be looking at a number called the correlation coefficient. And the cool thing about this number is we don't even have to, if we have it, glance at the graph and guess whether the correlation is positive or negative. We just know based on the number. So the first thing we're going to look at is how you denote a correlation coefficient. It's a lowercase, not a capital R. It's a lowercase r, which is why you'll also hear this called the R value. Ah, it is not doing well here, so let's clean this up. The R value. So if you hear R value or correlation coefficient, they are used interchangeably. So it measures two things, and this is really important that you know it measures two things. It measures direction. In other words, is the correlation positive or negative? And it measures strength of the relationship between the two variables, the strength of the relationship. You've got to remember it measures both things. Remember, we had that perfect positive and perfect negative correlation. They were both perfectly linear, just one had a positive slope and one had a negative slope. We're going to skip this. I want you to turn your paper over, and we're going to come back to it in just a minute, so don't turn your paper over yet. What the correlation coefficient does not tell us, what R does not tell us, is the value of the slope. The correlation coefficient for each of these sets of points is positive 1 because they are perfectly linear. That's what the 1 tells us, and we'll get back to that in a minute. And the slope of the line of fit is positive. But if you think about it, if I had the same scale on these two graphs, the slope of this line is actually greater than the slope of this line, but they both have a correlation coefficient of positive 1. Now, the reason we're going to skip this, and you're going to do this on the back of a sheet of paper, is what I'm finding is if students look at this as a number line, it becomes very confusing. So we're going to do this. 0 is no correlation. -1 and +1 are both perfect correlation. It's just whether the slope of the line of fit is positive or negative, but they are perfectly linear. Then you get down to -0.8 and +0.8. Between, and let me change the color here, between those and -0.99 and +0.99, between those two values, those are considered strong correlation. Which means, if I'm thinking that way, anything from -0.01 to +0.01, let's say, up to -0.79 and +0.79, all of those, anything in that range is considered weak. Now, it gets towards stronger the closer it gets to 0.8 or -0.8, but weak correlation. You will almost never see a scatter plot that actually, well, I probably will never see one that you put into a computer where it tells you the correlation coefficient is really 0. Chances are, if you look back at the ones we did the other day that just look like shotgun blasts and you have no idea how to draw a line of fit, the computer will find the best line, even if it's horrible, and it will give a correlation coefficient of, say, 0.2 or -0.15. So don't think of this as a number line where negatives are weak and positives are strong. 0 is weak, and the closer you get to either 1 or -1, the stronger it gets. And then 1 and -1 are your perfect correlations. Now, these are not the real correlation coefficients of these sets of data. It's just saying, okay, these are at least reasonable guesses for these. So 1 I know is a positive correlation, and it's perfect. And these points are perfectly linear, moving in a positive direction, so R equals 1. These are perfectly linear, moving in a negative direction, so R equals -1. I might even cross those off as I see them. The one that's the most scattered, where honestly I couldn't even draw a line of fit, would be this one, so R equals 0. The only difference, again, between 0.3 and negative 0.3 is these points would be increasing, these would be decreasing. So, 0.3, fairly scattered, but a positive line of fit, positive slope for the line of fit, so R equals 0.3. Fairly scattered, but the line of fit is negative, so R equals negative 0.3. Again, a strong positive correlation, but not perfect. So strong positive, not perfect, R equals 0.8. Strong negative, but not perfect. Strong negative, but not perfect, R equals negative 0.8. Again, notice these two have the same strength. The negative only tells us that the direction of the line of fit is negative. The positive only tells us that the direction for the line of fit is positive. You've got to remember that, or you're going to mess it up. Thanks.